Okay, let's do some more problems with forces. A 0.5 kilogram book rests on a table. A downward force of 6 newtons is exerted on the top of the book by a hand pushing down on the book. What is the magnitude of the gravitational force acting upon the book? What is the magnitude of the upward normal force exerted by the table on the book? Okay, so let's start out with A. Let's work on this one first, obviously. Well, I'm going to list the things I got. Well, no, I need to draw a picture. What's going on here? So we have a table. That's here. This is my table. Okay. Now, before I haven't drawn out all the problems, but we're going to start getting where you need to draw out a picture to see what's going on. And it doesn't have to be beautiful. I mean, this picture is beautiful, but yours does not always have to be beautiful. So we have a book there. It's a book that's 0.5 kilograms. Okay, and then here's our hand. That's a hand. Okay, there, I'll draw a hand. There's a hand being pushed down with, I'll draw that in a minute. Okay, so this is the scenario. A is what is the magnitude of the gravitational force acting upon the book. So, okay, so we're looking for F of G, force of gravity. Well, it tells us about this 6 Newton force that's exerted. Let me get my arrows out here. So there's a 6 Newton force. And that's from the hand. Well, that's not the force of gravity, so we don't care about that. That's not the force of gravity. That's from the hand pushing down. Okay, what we're looking for? What's this force of gravity? That's what we're looking for. So let's list the things that deal with the force of gravity. We need to know the mass. We know the mass of the book. It's 0.5 kilograms. Force of gravity, well, we also need to know the acceleration due to gravity. That's always 9.81 meters per second squared. In your book, it might round it up to 10, but I'm using 9.81. Okay, so, hey, we have two variables. We're looking for the third, and the equation, that's all we have in it, so we can just solve for the force of gravity. No, we did not care about the 6 newtons. That's not the force of gravity, that's the hand pushing down. We have multiple forces acting here. So let's work on B. This is going to require us to look at all the forces acting. So we have the, I might as well solve for this force of gravity. So let's take 0.5 times 9.81, 4.9. I'm going to round that to 4.9. Force of gravity equals that. That's newtons. So I'm going to write that in over here. So we have 4.9 newtons pushing down just from the force of gravity, and we have the hand pushing down another 6 newtons. So our total forces going down would be 10.9, right? So these combined would be 10.9. Well, the table, unless the table is going to break, and we're assuming it's not, the table has to push back with just as much force, because this book is not moving. It says, is the book accelerating? No, it's going to stay here. The table's going to push back. If it doesn't break, and we're assuming the table's not going to break, so it has to push back with the equal force that is coming down on it. So if there's 10.9 newtons pushing down, then that means this has to be 10.9 newtons pushing up, because we're not moving. Our F net is 0, right? So we add up all our forces to get the net. I'm going to say going down is negative, going up you're positive. So if we take a negative 6 newtons plus another negative 4.9 newtons. Well, that would give us a total of negative 10.9, so we have to have another force to cancel that out to get us a net F net of 0. So that other force is the normal force, the force that the table's pushing on the book. So we have another 10.9 newtons. That gets us 0. Okay. So basically you have to know that you're not accelerating because the book's just sitting there. It's resting on the table. So that means our F net is 0. That means there's no acceleration. And that also means all the forces pushing down must equal all the forces that are pushing up. So the table has to be pushing up a total of 10.9 newtons. Okay, well, I'll give you all the answers on that one. Let's do another one.